Hello and welcome to the review videos for Shaughnessy's class. Standard disclaimer here, please make sure you're attending class. These are just designed to be a quick tutorial of what the topics are that we are covering. So please make sure you're coming to class. Going with this, we're in rational expressions. This is lesson number 3, and this is really the first one where we start dealing with rational expressions. Okay. Now, rational expressions, as I was saying before, are fractions with x's in it, and that's kind of what we've got here. Okay. This little thing here says rational expressions, essentially a fraction involving x or some other letter. Since we cannot cut them using a calculator, we need to know how fractions work. Also too, as soon as we're dealing with rational expressions and x's, we need to remember how factoring works. Now, the definition of a rational expression, this is the formal definition. A rational expression is an expression of the form p of x over q of x, where p of x and q of x are polynomials and q of x does not equal 0. Q of x being the denominator of the expression. It can't be 0, and it can't be 0 for the same reason it couldn't be 0 in fractions. You can't divide by 0. See lesson 1 if you've got thoughts about that. Polynomials are things with whole number positive exponents on the x. So I asked just some questions at the beginning. Is this a rational expression? So when I'm looking at that, it's got to be a polynomial over a polynomial. And if I give you a, which is x cubed plus 2x all divided by 3x, those are polynomials in each case. Okay, whole number values of the exponents. So this is cubed, this is x to the 1, all good, over 3x. Yes, this is a polynomial. I'm going to write y. Okay, yes, this is. Okay, if I look at another one here, this one causes confusion. If I go 5 over 3x plus 2, yes, this is a rational expression as well, because even though we don't ever write it, there is an x to the power of 0 hiding in there. It is a whole number. It is positive or greater than 0, I guess. So this is a polynomial. So this would be yes. This is an example of one that wouldn't. Okay, the square root of x over 3x. The denominator is a polynomial, but the top isn't. I've got a square root of an x, which would be x to the power of 1/2. Check the exponent laws. So this would be a no. This would not be a rational expression. So when we're working with rational expressions, we're working with polynomials over polynomials, which means we can use the factoring, we can use all of that sort of idea and go from there. Now, the first thing I want to talk about rational expressions, and this is the first thing you'll need to know, is non-permissible values or restrictions. Because we have x in a denominator and we can't divide by 0, sometimes we have to restrict x. Okay? We're just not allowed to have whatever it works out to be. Whatever that expression is, we can't have the denominator of 0. And so we end up having to come up with restrictions. For example, this one here, if I give you 5 over 3x and I want the NPVs. Okay, if I want the NPVs or non-permissible values, NPV or restrictions on this variable, basically what I know is I know that the 3x, the denominator, 3x cannot equal 0. It's not allowed to equal 0. Now I'm going to finish this off a little bit and say, well, what else do I know? I can divide both sides by 3. I use my algebra. The 3's cancel here. I'm going to get x cannot equal 0 divided by 3. I am allowed to do 0 divided by 3. Remember, see lesson 1. 0 divided by 3 is 0. So there's my non-permissible value. There's this restriction on this variable. So what essentially that means is if I'm doing a graph of this or if I'm looking at this, x can be anything mathematically except 0. can be anything else. It can be any number, positive, negative. It can be decimals. It can be square roots. It can be anything, but it can't be 0. So that's what the restrictions are. That's what the non-permissible values are. Looking at that 0 there, I've got a few different options, e.g. 5 over x plus 2. Now if I do 5 over x plus 2, that's my rational expression. We're all good with that. But this tells me, well, I'm not allowed to divide by 0. So this numerator, the denominator, sorry, can't be 0. So x plus 2 cannot be 0. I use algebra to finish that off. There's a plus 2, so I'm going to subtract 2. And what I get is x cannot equal negative 2. And that is my restriction. X can be anything in this expression except negative 2. And you can just keep going with these sorts of ideas, okay? If I do examples like this, okay? 8x squared plus 2x all divided by 3 times x plus 4. Okay? So I've got this. I've got x's in the numerator this time. This is the first one I've had. But it doesn't matter if there are x's in the numerator. Whatever's going on here, non-permissible values or restrictions or NPVs, only concern yourself with the denominator. So the denominator, this 3 times x plus 4, 3 times x plus 4 cannot be 0. Now, you could divide both sides by 3, or you could make a real argument 3 times something. That 3 is never going to matter. So I'm going to divide by 3 and get rid of it. So I'm going to get x plus 4 cannot equal 0. I still haven't finished off my non-permissible values. What can x not equal? So I subtract the 4 to both sides, minus 4, and I'm going to get x cannot equal negative 4. And that's my restriction. That's my non-permissible value. Okay, I can look at ones that have come with a whole variety of different options. Okay, here's one, 13 over x plus 4, x minus 2. Now, right now on first glance I say, well, I'm not sure if this is a polynomial. I could multiply this out. I could see it's a polynomial. So this one here, what are the non-permissible values here? Well, as always, that denominator cannot be 0. So x plus 4 times x minus 2 cannot be 0. Now this is a quadratic equation. You spent 20-2 or 20-1, depending on where you came from, solving these, so you know that each piece could be 0. So in this particular case, each piece cannot be 0. So you get that x plus 4 cannot equal 0, or x minus 2 cannot equal 0. So you end up with a couple different options. Okay. Now going with that, here subtract the 4 to both sides. I'm going to get x cannot equal negative 4, and I'm also going to get, add the 2 to both sides, x cannot equal positive 2. So in this particular case, okay, in this one here, I've got two restrictions. X can be anything except it can't be negative 4 and it can't be positive 2, but it can be anything else. So these are my non-permissible values, my restrictions, things that I'm not allowed to have. Okay. If I look at a few other examples, and I'm just deliberately kind of switching paper here a little bit. There's that top of that paper. If I look at ones like this, sometimes it's not clean yet. Okay, if I go e.g. In the middle of the page there, e.g. 7 over 3x minus 9, and I want to know the non-permissible values here. Well, I know that 3x minus 9 cannot equal 0 because it's from the denominator. Move the 9 over, I'll get 3x cannot equal 9. Divide by 3, x cannot equal 9 divided by 3 is also 3. So there you go. I get that. Sometimes I can say these, e.g. Okay, what about 13 over x squared minus 9? Okay, now you could factor this or you could solve this algebraically. Either way, you're going to end up with a few different options. Okay, I can say that x squared minus 9 cannot equal 0. Factoring that, I could say that x plus 3 times x minus 3, because that's a difference of squares, cannot equal 0. Using what I know from the previous page, I get that either x plus 3 can't equal 0, or x minus 3 cannot equal 0. So that tells me x cannot equal negative 3, or it tells me x cannot equal positive 3. Some of you are saying, Shaughnessy, could I do it a different way? I say, what? You say this. Well, if x squared minus 9 cannot equal 0, x squared cannot equal 9. So I take the square root and I'll get x cannot equal and the square root of 9. And I say, what's the square root of 9? And they say 3, and I say, almost. The square root of 9. What two numbers multiplied together will give you 9? Well, there's a positive 3 and a negative 3. Okay, remember, any square root could be positive or negative, so that's where you end up with the plus or minus 3. Either way, you get the same two numbers, positive 3 and negative 3, positive 3 and negative 3. Either way, you get the same two numbers, but you've got to kind of go with it from there. Okay. So if I look at these ones here, e.g., okay, 18x cubed plus 4x plus 1 divided by 4x squared minus 25. This is a nasty one. Remember, I've given you a big thing in the denominator or in the numerator, but the numerator doesn't matter. If I'm looking for non-permissible values, I'm only concerned with the denominator. So I get 4x squared minus 25 cannot equal 0. Now, you could solve this other way here with moving the 9 over. I don't want to. I look at this and see, oh, it's 2x all squared minus 5 all squared. So there's my difference of squares. It's going to be first piece plus second times the first piece minus the second. Continuing on, 2x plus 5 can equal 0, or 2x minus 5 can't equal 0. Move the 5 over, 2x can't be negative 5. So divide by 2, x cannot equal negative 5 halves. Yes, it's a fraction. So what? Okay. Negative 2.5. If you prefer a decimal, you could do it. Over here, move the 5 over, so I'll say 2x cannot equal 5. Divide by 2, x cannot equal positive 5 halves, or positive 2.5. Either way, it's still going. Okay. Now, going along with that, once you're comfortable with that idea, then we have a few other little things. Now, the one thing that I want to talk about is this. At the bottom of this page, because I admittedly kind of jumped because I didn't leave enough space. Sometimes we may notice a restriction canceling out. And it might. If I reduced it, it might cancel out. But even if it cancels out, it's still a restriction of the original question. So if I go e.g. x plus 2 over 4x plus 8, okay, look at the denominator. 4x plus 8 can't equal 0. So 4x can't equal 8 or negative 8. So x cannot equal negative 2. That's my restriction. Even though, and you'll know this more about this tomorrow, but even though if I look at this, I can say, well, by reducing, that's x plus 2, and in the denominator it's a 4 times an x plus 2, and the x plus 2's are common factor, and they're gone. And once the x plus 2's are gone, then I don't have this restriction, because the x's are gone. It doesn't matter. Even if it cancels out, it is a restriction. So going through just a little bit more, one of the things we ask you to do in this class, prove it's a non-permissible value. Show me by substitution that it's a non-permissible value. So show if each value. So I'm just going to say, show me that 4 is a non-permissible value of x squared plus 2 over x minus 4. Now how am I going to show that? I'm going to plug it in. So if I plug in 4, I'm going to get 4 squared plus 2 over 4 minus 4. 4 squared is 16. 16 plus 2 is 18, so oh, that's good. 18 over 4 minus 4 is 0. This can't be done. This is illegal. It's an illegal math operation. So because of that, 4 has to be a non-permissible value, because when I use 4 and I plug it in, I have to do something illegal in order to use it. And since I can't do something illegal, that's why it's a non-permissible value. It just requires me to do that. Okay? If I ask you, is 5 a non-permissible value? So here's an example. Is 5 a non-permissible value of x minus 5 over 2x plus 6? Okay, is this a non-permissible value? It's a question mark. Is that a non-permissible value? Well, I'm going to check it by plugging it in. So I'm going to get 5 minus 5 over 2 times 5 plus 6. And what I'm going to end up with, 5 minus 5 is 0, and I'm going to 10 plus 6, because 2 times 5 is 10, plus 6 is 16. So I end up with that, 0 over 16. So I've got a 0 occurring, but where is that 0? Since that 0 is in the numerator, it's allowed. I'm allowed to do this. So is this is not an NPV or non-permissible value or restriction or whatever, because this isn't illegal. I can do 0 divided by 16 and all is said and done. It's all good. Okay? So on and so forth. So you're checking. This, I cannot emphasize this enough. Common error. Okay? People, students, especially by the time they get to their diploma, they say, well, 0 is a non-permissible value. I remember zeros having something to do with non-permissible values, so 0 is always an NPV. This is not true. X can be 0 in some cases. In fact, most of those cases that I gave you, if you look at the examples, I was saying repeatedly, X can be anything except 3. So if it can be anything except 3, yes, it can be 0. It could be decimals, it could be fractions, it could be anything except 3. Here, x could be anything except positive or negative 3. Here, x could be anything except negative 2.5 and positive 2.5. So in these 3 examples here alone, I can have 0. 0 is allowed. It's not non-permissible. It is perfectly permissible. So because of that, I have to allow it. But a very common mistake on an exam, stress situation, 50% of your final mark for a diploma, people say non-permissible value is 0. It is not true. The value of x can be 0. It is important to check what the denominator is before making the final decision on NPVs. Please make sure you check that. Please make sure you look there, because it could be 0, and it's not an always thing. The denominator itself can't be 0, but x might. Have a wonderful day. Talk to you soon.